In DTF printing, print inconsistency does not always begin with ink, artwork, or print head failure. Sometimes it begins with film tension. The print may look acceptable at the start of a job. Then alignment becomes less stable. Solid areas show density variation. Fine details shift, bending, stretching, or uneven layer formation appears, even though the settings have not changed. Under stable conditions, uniform tension keeps the film at a consistent distance and orientation relative to the print head, so droplets land predictably. When tension becomes uneven or fluctuates, that stable relationship breaks down. The film may still look flat and keep feeding forward, but at the print zone, small positional changes can create visible inconsistency. The manufacturing lesson is simple. Tension is not only about pulling film through the printer. It controls the spatial stability of the print surface. A DTF printer depends on a stable relationship between the print head, the film surface, and the movement path. The print head fires droplets, and the film receives them, and the transport system moves the film through the print zone. Tension connects these parts mechanically. If tension is even, the film moves smoothly and holds position. If tension changes across the ways or fluctuates during movement, the film no longer behaves as one stable plane. One area may be pulled more, another may lag, relax, or shift. These changes can be tiny, but inkjet printing is sensitive to small position errors. That is why tension defects often appears as stable alignment shifts, bending, stretching, or density changes. The printer continues to operate, but the film is no longer presenting a stable target. Uneven tension can come from several parts of the system. Roller pressure is one direct cause. If pressure is uneven, one side of the film may be gripped more strongly than the other. That creates uneven pulling force across the ways. Mechanical alignment also matters. If rollers, guides, or the film paths are slightly misaligned, the film can experience diagonal stress instead of moving straight. Drive synchronization matters too. If feeding components do not move at the same rate, tension can rise and fall. Film structure affects response. A stiffer film may resist deformation, but transmit force differently. A more elastic film may absorb variation, stretch, or respond with delay. The question is whether the film and the machine are balanced. Surface interaction matters as well. If friction at the rollers and guides is inconsistent, tension is not transmitted evenly. A small contact difference can become a force distribution difference. Humidity and temperature changes how the film responds to the tension. Under lower humidity, film becomes stiffer, with less ability to absorb force variation. Uneven tension may appear as positional instability. Under higher humidity, film can become more flexible. That can absorb stress, but it may also create delayed response if the film does not return consistently. Temperature can affect dimensional stability, internal stress, and roller movement. So tension is not isolated from the environment. The same setup can behave differently when the film's mechanical response changes. That is why a print run may look stable in one condition and unstable in another, even with the same settings. The important point is that tension variation does not need to be large. DTF printing builds an image through repeated presses and droplet placement. If the film shifts slightly, each pass may land in different relationship to the previous one. That can create bending, soften edges, stretching patterns, or uneven density. And when instability begins, it can affect the next part of the process. A slight positional shift changes ink deposition and wet layer formation. That can affect powder distribution, bonding, and transfer consistency. So a small transport stage tension problem can move through the whole DTF process. That is why the defect often becomes more visible over time. If tension imbalance is not corrected, variation is enforced rather than neutralized. One confusing part is that tension problems do not always stop the printer. If the transport system completely failed, the film would jam, stop, or lose feed control. But many tension problems happen inside a partially stable range. The printer keeps moving the film forward, but not uniformly. The partial instability is exactly what creates print inconsistency. The process is stable enough to continue, but unstable enough to disturb quality. This also explains why short tests may miss the issue. During longer production, small force differences have more time to become visible. Film tension inconsistency is not usually caused by one setting. It is not limited to one film thickness, not always a mechanical defect, not automatically an ink problem, and not always visible as curing or feeding failure. Tension comes from interaction between film, rollers, drive system, alignment, surface contact, humidity, temperature, and printing movement. If one variable is adjusted without understanding that interaction, the problem may improve temporarily and return under different conditions. The better diagnostic question is not which setting is wrong. The better question is where is force distribution becoming uneven. When troubleshooting print inconsistency, look at the pattern of the defect. If the issue appears gradually during a long run, tension should be a part of diagnosis. If one side behaves differently, check roller pressure, alignment, and tracking. If bending or stretching appears without a clear ink or artwork change, check movement under the print head. Also consider material response. A film that is stiffer, more elastic, poorly acclimated, or affected by humidity may respond differently to the same tension setting. The goal is not to blame the film or machine alone. The goal is to understand the system. Stable print consistency requires stable force distribution. Film tension affects print consistency because it controls movement and the position under the print head. When tension is even, The film presents a stable printing surface. When tension becomes uneven, localized force imbalance creates small positional variations. Those variations disturb ink deposition, layer formation, powder behavior, and transfer consistency. The causal chain is clear. Uneven tension distribution leads to localized force imbalance. That creates positional variation, changes the relationship between film and the print head, and becomes visible print inconsistency.